Today we're going to talk about statistics. So all of chapter 12 that we're going to be looking at, we're going to be doing kind of a brief survey of some different topics that are useful in statistics. So the study of statistics was originally used by governments to manage large amounts of numerical information. The use of statistics has grown significantly and today is applied in all walks of life. Probability, which we just talked about in chapter 11, and statistics are closely related. Someone in the field of probability is interested in computing the chance of an occurrence of a particular event when all the possible outcomes are known. So that was looking at our different types of probability that we saw in the last section, where we were taking a particular event that we were looking at and figuring out the chance of that happening. As far as statistics go, a statistician's interest lies in drawing conclusions about possible outcomes through observations of only a few particular events. So here we're going to take events about a smaller group of data, individuals, information, and then use that to hopefully kind of generalize something about the bigger picture. Okay. So we're going to start with a couple of definitions. Right, so our first definition is that of actually the word statistics. Statistics is the art and science of gathering, analyzing, and making inferences or predictions from numerical information obtained in an experiment. The numerical information obtained is referred to as data. Statistics allows us to do a few different things. It allows us to explore different things in the world around us, use evidence to check whether or not our beliefs are true, find patterns that could potentially lead to discoveries, share these new discoveries with others. As we're going through these problems, yes, statistics gives us a lot of power in being able to do different things, but we do want to keep a few things in mind. They must be used carefully. So statistics must be used carefully as far as our interpretations and different decisions or results that are based off of that. Inappropriate use will result in inaccurate beliefs, and results are always uncertain. So if we're making some sort of prediction based on statistics, it's not necessarily 100% guaranteed that it works out that way. It's just a good logical guess. So when we're thinking about statistics, we have two different main branches of statistics, descriptive and inferential. So our first type is our descriptive statistics. So descriptive statistics is concerned with the collection, organization, and analysis of data. In the section 12.2, we're going to look a lot at this type of statistics. We're going to talk about how we can organize and easily present data and information so that others can summarize it and analyze it as needed. Our other type of statistics is inferential statistics. Inferential statistics is concerned with making generalizations or predictions from the data collected. So inferential comes from the word inference. So again, we're making predictions or guessing about kind of larger issues than maybe we're just given in the information or data that we collect. All right, so at the top of the next page, we have a few more definitions that we need to go through. A lot of this first section is actually definitions. All right, so our first definition on this page is going to be that of a population. A population is a data set that contains all elements or people of interest. So when we're looking at the word population, our key word that we're looking at here is the word all. So are we looking at the entire population of America? Are we looking for the entire population of South Suburban College? So are we looking at all of the residents in a specific city? So when we're thinking population, we're thinking about the word all. So it's a collection of all data values that will ever occur for a group. It's often difficult to obtain all of this information, right? It's the reason that the census only happens, once every 10 years. It's difficult to obtain information from all of the people in the United States. Right? If we are able to obtain this information about all people in a particular group that we're looking at, the numerical value that results is called a parameter. So a parameter is the numerical value that characterizes some aspect of the population. Easiest way to remember this, parameter and population both start with the letter P. Right? So we just mentioned it's difficult to contain or to collect information about an entire population. So oftentimes what we do is we collect information about a sample. So a sample is a subset of the population being studied. Right? It's used to represent our population. It's way easier to obtain our information from a sample rather than an entire population. And this also gives us another definition of the word statistic. A statistic is a numerical value that characterizes some aspect of the sample. So as we're looking at these, the biggest thing to remember, population and parameter, they both start with the letter P, they go together. Parameters are numerical values about populations, and samples and statistics go together because they both start with the letter S. Right? So a statistic is a numerical value about a sample. Sometimes a statistic is referred to as an estimator because we use statistics to estimate parameters. Right? We use samples to estimate information about populations. Right, so our first example, we're given a couple of different pairs of groups of people. We want to decide which one is a parameter, which one is the statistic. Or excuse me, which one is the population, which one is a sample. Excuse me, we're not looking at the number values here, we're just looking at the groups. All right, so all students at SSC versus all students taking a math class at SSC. Right, so our larger group is going to be the population. So in this case, our population is going to be all students at South Suburban, right? And our sample is going to be those that are taking a math class because that is a smaller group. Now, if we take all students at South Suburban and compare them to all community college students in Illinois, well then our students at South Suburban are no longer the population, they're the sample, right? And they are the smaller group, right, that may be using to represent the state of Illinois. So all students at South Suburban are going to be the sample, excuse me, and all community college students in Illinois is going to be the population. Right, example 2 at the bottom, again, is just kind of exploring this vocabulary a little bit further. A researcher is interested in studying the heights of American women. She takes a random sample of 1,500 American women, finds the mean height of the sample is 63.6 inches. Determine the sample and the statistic. Right? So the sample is the 1,500 American women that are sampled. Right? The statistic is a numerical value that is found. So it is going to be the mean height of the 1,500 women is 63.6 inches. And then we can use our statistics to estimate our parameters. So in this case, we're looking at our mean height of just the 1,500 women that were sampled. But we can use this statistic to estimate our parameter. So the researcher may estimate that the mean height of all American women, right? Because a parameter is about a population includes the word all, is 63.6 inches. So again, a lot of this section is just going to be introducing us to some different vocab, some different things that we want to keep in mind as we're going through the next few sections. So the first kind of sets of vocab words that we're looking at, make sure you know the definition of statistics, and make sure you know the difference between populations and parameters versus samples and statistics. All right, the next thing that we're going to talk about are different ways that we can collect our samples, and then calculate or identify statistics that are then used to make estimations about our population. So our first definition that we have here is that of an unbiased sample. An unbiased sample is one that is a small replica of the entire population with regard to income, education, gender, race, religion, political affiliation, age, and so on. So basically, any sort of criteria that we look at, our sample is a good representative of a lot of different variables or factors in that population. Right, the following sampling techniques will give us a brief idea of how statisticians obtain unbiased samples. All right, so our first type of sample is a random sample. A random sample is drawn in such a way that each time an item is selected, each item in the population has an equal chance of being drawn. So maybe we're talking about drawing marbles out of a bag, or randomly selecting people out of a certain population. Right? When we're using a random sample, one combination of a specific number of items has the same probability of another. And as far as generating these random samples, a good way to do this is using a random number generator. So a lot of different computer software, different things along these lines have ways to generate our random samples based on technology. Right? As far as the different types of sampling that we're going to look at, we're going to look at 5 different types of sampling. This by far is the best way to select a sample. Right, our next method for selecting a sample, right, is going to be something that we call a systematic. A systematic sample is obtained by selecting a random starting point and then selecting every nth item in a population. Right. So when we're selecting systematic samples, it's important that we're selecting from the entire population. And then one other thing that we must avoid is that we have a constantly recurring characteristic that's not shared by all members of the population. So kind of an example of selecting something systematically is maybe we pick every 5th person that does something, or every 5th item, or every nth item means we select so many different things, and we hope that we get something. It's not exactly random, but we hope that we get something that's close to being random. A cluster sample consists of a random selection of groups of units. So cluster samples are sometimes referred to as area samples because we can sometimes select certain geographic areas. To select a cluster sample, we divide a large, or specifically in some cases a geographic area, into sections, and then we randomly select different sections or clusters. The next type of sample, we can pick a stratified sample. A stratified sample is drawn from a population by we divide it into parts, and then out of those parts we take a random sample from each different group. So the difference between cluster samples and stratified samples, cluster samples we're selecting entire groups, stratified samples we're selecting different tiny groups within our groups, or little subsets of our subsets when we're thinking about our population. And so these 3 lists of, or different ways of selecting samples that are listed in the middle, these are all pretty good ways of selecting samples. Not necessarily as good as a random sample, but much better than our last option. So our last option down here at the bottom is a convenient sample, right? And we call it a convenient sample because it's easy, right? It uses data that are easily or readily obtained. The only problem is sometimes data that are conveniently obtained, they may be the only data available. So in some cases, some information may be better than none at all. But the only problem is with convenient sampling, it may be biased. So because they are easy to select, it may not necessarily be the most representative of our population. Right? So if our random sample at the top was our best, right, then this one down at the bottom is our worst, right, way of choosing a sample. And then the 3 guys in the middle are just kind of all in the middle together. Right? So we have 1 that's the best, 1 that's the worst, 3 that are kind of in the middle together. All right, in the next example, we're going to try to identify the sampling technique in each of these different problems. How did we select the sample? So identify the sampling technique used to obtain the sample in the following. Explain. Right, so every 20th can of soup coming off an assembly line is checked for defects. Right, this is going to be an example of systematic sampling. Systematic sampling was the case where every nth, in this case 20th, item is checked. For B, a $50 gift certificate is given away at the annual bankers convention. Tickets are placed in a bin, the tickets are mixed up, the winning ticket is selected by a blindfolded person. Right? This is going to be an example of a random sample. Right? The key thing in a random sample, each has an equal chance of being selected. So the fact that they're mixed up and it's drawn by something that's blindfolded means each has an equal chance of being selected. Right. So for C, children in a large city are classified based on the neighborhood school they attend. A random sample of 5 schools is selected. All the children from each selected school are included in the sample. Since we are selecting entire groups, this is an example of cluster sampling. Right? So entire groups, in this case they are geographic and area by school. All right, they could be geographic and then again they might not be, but in this case they most likely are, right, are selected. Right, so cluster samples, entire groups are selected. All right, for D, the first 50 people entering a zoo are asked if they support an increase in taxes to support a zoo expansion. This would be an example of a convenience sample. Right? It is easily obtained. Right? Someone could easily gather data just by standing outside the door for a few minutes and asking the first 50 people that walk by. Right? It might not necessarily be representative of the entire population based on who was going to the zoo that day, or there's special events going on the zoo, people that are going to the zoo compared to people that might not be. So it would be a sample of convenience rather than one of the other methods. All right, and then example E, all registered vehicles in the state of California are classified according to a type: subcompact, compact, midsize, full-size, SUV, and truck. A random sample of vehicles from each category is selected. So this would be an example of a stratified sample. Right? Again, stratified and cluster samples are similar, but when we're dealing with cluster samples, entire groups are being selected. When we are talking about stratified samples, right, we're talking about smaller subsets of each group. Right? So our strata is based on classification. And representatives from each strata are sampled. So there's a good chunk of homework problems that are asking you to identify our different sampling techniques. It'll give you a small scenario and they ask you, based on that scenario, which is a sampling technique that is being used. The last thing that we're going to talk about this section is some common misuses of statistics that we want to avoid. So statistics, when used properly, is definitely a valuable tool, right? That's the reason it exists. That's the reason that it's studied. And that's the reasons that we're talking about it. However, many individuals, businesses, and advertising firms misuse statistics to their own advantage. Right? So when you come across statistical statements or graphs, you definitely want to take a close look at them before you accept them as fact. You should ask yourself, was the sample used to gather the statistical data unbiased and of sufficient size? Right? So based on the type of sample, if you know that it was a convenient sample versus if it was a random sample, that might influence your decision. Right? Is the statistical statement ambiguous? Right? Can it be interpreted in more than one way? Is the graph drawn in a way that's misleading? Often in publications of different types or people that want to prove a point, they may release images that are similar, but kind of made to look or emphasize one fact over another. So using a different scale, using different percentages that add to more than 100% or something along those lines. All right, so our last example in this section, we're going to try to identify some examples of misuse. Okay. So for example A, 4 out of 5 dentists recommend sugarless gum for all their patients who chew gum. Right, so we want to discuss the statement and then tell what possible misuses or misinterpretations may exist. Right, so what we're given here, we're not really given a lot of information. Right? So we could say that our sample size is unknown. That could cause us reason to suspect this. We could say that the actual question that people were asked is unknown. And our data to back up the claim is also unknown. So in this case, it's more just kind of an idea that we don't really know much about this. Right? Where did it come from? Where is this claim coming from? Can we trust it? Okay. For B, the average salary of Company A's employees is $45,000 and the average employee's salary for Company B is $40,000. Therefore, Company A is better than Company B. This would be an example of a statement that is ambiguously worded. Right? So there are many interpretations of the word average. Right? And more specifically, we're going to see a few of them in section 12.3. We're going to talk about mean, median, mode, as well as some other things, so different ways that we might think of the word average. So it's ambiguously phrased. Just because one company's average is better than the other, we don't really know what types of averages are being compared. We don't really even know what we mean by the word better in this case. Right, a department store claims it is the largest department store in the United States. Therefore, this department store is the best. Largest, right, best, right, is another vague or ambiguous word. Right? So you want to be careful when you're reading things that claim that they're the best or they're the biggest or they have the best average or they're the largest. Right? We don't really know what method they're using to compare these different things. Right? Company C claims that its paper towels are heavier than its competition's towels. Therefore, they will hold more water. But the thing that we want to think about it, well, even if they're heavier, does that mean that they are better at absorbing liquid? So is weight a measure of absorbency? Right? We don't really know, right? In this case, it could be connected, but if we were to compare other things, if we were to compare a rock, for instance, versus a sponge, well, a rock is definitely heavier than a sponge, but a rock won't necessarily soak anything up like a sponge would soak up liquid, right? So I'm also going to make a little note here. Irrelevant conclusions, right, or comparisons, such as, right, trying to compare a rock to a sponge. So weight can't be our only indicator of absorbency. Weight can't be our only indicator of which one will hold more water. Right, and then last but not least, in example E, both bar charts report the same data. Why is the first image misleading? Right, if we look at these two images, our scales are different on both of these. Right, so on the left, we go from 1.20, 1.25, we go up by teeny tiny values. Where on the right, we actually have a good variety of ranges. Right, so in this case, this first image, is going to be misleading. Right? And we're going to say that it has inappropriate scaling. Right? The y-axis does not start at 0. And because of that, it causes a more dramatic appearance. So the last few sections in this, or the last few homework problems, in this section are going to ask you to identify different ways that statistics could possibly be misused or be misrepresenting a data set. So as I mentioned at the beginning, this first section is mostly vocabulary. Pay attention to population parameter versus statistic and sample. Pay attention to our different types of sampling techniques. And then also, as we're looking at different statistical data that we are presented with, we want to make sure that we are getting a good, accurate portrayal of what's actually being given to us.